Afternoon to you. Thanks very much indeed for being with us. When you first saw this image, what did you think?
It was a really wow moment for me, to be one of the first people to ever see an image of a black hole, a real image, not an artist's impression. That was really a wow moment.
Yeah, did you ever think you would see that kind of image in your lifetime as a scientist?
So this is something that people have been working very hard on for the last 20 years. So we knew it was in sight. We knew we just had to push a little bit harder to get there, but it's always awe-inspiring to see the final result.
Sure. One wonders exactly what a black hole is. Now, I'm an idiot. Explain it to me.
Well, essentially, it's very simple if you boil it down to the nuts and bolts. If you just put enough mass in a small enough region, then it becomes very hard to escape that gravitationally. Like on Earth, we have to put things on big rockets in order to get them to escape Earth's gravity. If you put enough mass together, you get something so dense that not even light can escape. And that is just called a black hole.
A huge black hole. So what are we likely to learn from this image then? How is it going to help us?
So this image reveals so much about the black hole itself. So its mass, it's about 6 billion times the mass of our own sun. It shows us that the black hole itself has to be rotating, and the disk of gas around it is also rotating. So those are all exciting new discoveries, and it really shows us that Einstein was right. His theory predicts this almost perfectly, and that's very exciting to know.
All right, so it's good to know that he wasn't talking a load of old nonsense, Mr. Einstein. But how could this sort of analysis of this now, how can that help us sort of practically here on Earth, do you think?
So this is a huge technological challenge to do this. The antennas all over the Earth had to be synced up one-to-one using atomic clocks. And this sort of pushing the boundaries in technology always leads to new and unexpected technologies. For instance, the wireless internet we all enjoyed, that was originally created by radio astronomers who wanted ways for their antennas to talk. So there's so much that we can learn for technology here on Earth, and the value of collaboration as well. This is an international collaboration of 200 plus scientists across the globe. So that's also important in today's climate to acknowledge that as well.
Indeed, global cooperation. We heard one scientist there in that piece from Pallab Ghosh describe this as looking at the gates of hell as at the end of space and time. I mean, that's a lot of hyperbole in there. Would you agree with that?
It's certainly a very extreme environment. I mean, the glowing gas that you can see there is at 1 billion degrees Celsius, and the gravitational pull there would pull us apart very, very quickly indeed if we were to venture too close. So it's definitely a place in the universe I wouldn't want to visit personally.
No, I suspect not. Well, it's good to see you, Tim, and congratulations to you and the team involved in all this. Dr. Tim Davis there, speaking to us from Cardiff University. Thank you.